Hi everyone, I'm Amanda here from the Green Bank Science Center, and today I have joining me Dr. Toney Minter, a staff scientist and head of GPT science operations here at the Green Bank Observatory. Thanks so much for joining me today, Toney.
Well, thanks for having me.
So we're here to talk about an exciting NASA mission happening right now. The mission's name is Mars 2020, as the departure occurred last year, but we have an exciting event happening in just 2 weeks. Toney, can you tell us a little bit about this mission?
Yeah, so NASA has launched Mars 2020. That happened last summer, and the mission will actually be arriving at Mars in a few weeks on February 18th, and they'll be going through what's called EDL, ascent, our entry, descent, and landing through the atmosphere and landing on the surface of Mars. And this mission has a Perseverance rover, which will be the primary component of the mission.
That's so exciting. And as you mentioned, that's in 2 weeks, February 18th. And that's a really important and really intense part of this mission. So I wondered if you could take us through some of those important steps of these critical landing stages.
Right. Besides launch, this is probably the most dangerous part of the mission is actually going through the atmosphere of Mars, slowing down enough that you can land on Mars and then safely begin operations of the Perseverance lander. First thing to know is that it's not like a spacecraft coming back to Earth with an astronaut. Uh, there you have a heat shield on the spaceship that deflects all the heat from where the mission starts coming through the atmosphere. It starts heating things up. That heat shield keeps everything, especially the ash, from baking. And then coming back to Earth, you can, once you slow down enough from the drag from the atmosphere, it's the same as sticking your hand out the car. When you're going 60 miles an hour down the road, you feel that pressure. It tries to slow your hand down, pulls it backwards. Same thing happens to the spacecraft. It slows down in the Earth's atmosphere. It eventually gets slow enough that you can pop a parachute open, and then that slows you down enough that you can rather gently land on the ground and survive the impact, and it's not too much for you. But on Mars, it's a little bit different situation. The Martian atmosphere is much, much, much thinner than Earth's atmosphere. There's more atmosphere on top of Mount Everest on the Earth than there is at the surface of Mars. So
Oh, wow.
there's not much there to help slow you down. But so Perseverance will start coming into the Martian atmosphere. It'll still have to have a heat shield to protect it because it will slow down a good bit. And it will get going slow enough that a parachute will open and it'll slow it down even more. However, the Martian atmosphere is so thin that it never slows down the spacecraft enough that it can gently touch down on the ground. So you have to put in extra features. So there will be a radar on the lander that will look at the ground, and when it detects that it's a certain height above the ground, it then releases the spacecraft. It then uses rockets to control the descent and slow it down even more. Yeah. Otherwise, there's no way to slow you down enough to land. And they'll be using the sky crane again for this mission. They used it for one of the last rovers. I believe it was Curiosity. And they hover the sky crane above the ground, sort of like you can imagine a helicopter lowering something to the ground, except rather than using blades, this is using a rocket. And then it just lowers the Perseverance rover to the ground, lets go the cables, and then the rocket part of it will fly off and hit the ground somewhere else, and you'll have a rover sitting on the ground ready to run.
Wow. Well, that's really involved and really intense, but this has happened successfully a couple times. As you mentioned, one of them, we were provided backup for another mission in 2018, the Mars Insight lander that happened very successfully. We were excited about. So one reason that we are particularly excited about this mission is because the Green Bank Telescope is involved again. Dr. Will Armentrout will give us a little more detailed information about this next week. But can you give us a summary of what the GBT will be doing during this particular mission?
So the GBT is an added on feature for the mission for NASA, and that the GBT is a large enough dish, a little good bit bigger than most of the Deep Space Network dishes, that it can actually see the lander itself as it's coming down to the surface. So typically the way that the Mars missions operate is the rovers on the ground have a little smaller transmitter in them so that they relay that signal up to a satellite orbiting Mars, and then that satellite's responsible for sending the signals back to Earth. But with the GBT being a little bit bigger and more sensitive, we can actually see the signals from the landers directly, and we give us another look at what's going on during the descent. And so what happens is the lander's coming down, it's going to change speed as it slows down. And the GBT will be able to identify that change in speed as it goes down. And so you can follow what's happening, and they can tell how fast the spacecraft's going and where it lands. Now, the way to think about this is actually something people experience all the time. It's physics you know, but it might not be physics that you know, if that makes sense. Probably one of the easiest things for people to think about are race cars, what they sound like. So if you're actually inside of a race car, this is somewhat what it would sound like. It's just a constant sound. It's not changing in pitch or tone or anything. That's because the motor in the race car is making all the sound, and the person in the car is moving at the same speed as the motor. So the distance between them is not changing at all. So it sounds the same the whole time. Now, if you're a spectator in the stands and a race car goes by, it sounds a whole lot different. So it'll sound something like this. So you get that zoom sound.
Mm-hmm.
What's happening there as the race car is coming towards you, the race car is actually catching up with some of the sound that it emitted. So it's kind of scrunching the sound up, and that makes the sound higher, more the Z sound.
Mm-hmm.
And then as the race car is going away from you, it's getting further and further away from the sound, and the sound actually has harder time getting back to you. And that's when you get the lower tone sound. The same thing actually happens to light, which is what the radio signals are. There's a spacecraft who's coming towards you. It's actually catching up to the light some and making it the waves appear closer together or higher pitched. And it actually makes things look bluer. So it's called blue shift. But when the spacecraft's going away from you, the wavelengths get longer, gets that lower tone, and that's called red shift. So the same way that your ears can tell the race cars coming towards you or away from you, mm-hmm. we can use the same thing with light to tell whether the spacecraft's coming towards us or away from us. And by measuring what color that light is, we can tell the exact speed.
Oh, wow.
So as the spacecraft's coming down through the Martian atmosphere, it has a special signal that's essentially one color that's known. And we will measure that change in color so we can see how fast the spacecraft's moving, how it's changing speed. So we can tell that it's going through the descent. When the parachute opens, you'll see a big change in the speed. And then when it finally lands, the speed more or less stops changing. At that point, you can tell that it's on the surface.
That's really impressive. And thank you for putting that in terms that some of us without all of that knowledge can understand. So in talking about this entry, descent, and landing, how long does this process take?
It takes approximately 7 minutes. It's why NASA's started calling this the 7 minutes of terror.
That's
because it
very
is
fitting.
one of the most dangerous parts of the mission. It's when they, it takes one little thing going wrong, and you have, rather than one operating piece of equipment on the surface, you have many pieces scattered around that don't do you much good. But if you remember last summer, Mars was really close to Earth,
Hmm.
and that's when they launch. That happens every 2 years. Since roughly Mars takes 2 years to orbit the sun when the Earth takes one. So every 2 years they line up pretty close together. And the reason that missions launch at that point in time is because the less distance you have to travel, the less fuel you'll need. And that
Sure.
makes the launching the rockets a lot cheaper.
And how long, so EDO happens in about 7 minutes. How long does it take for the GBT to receive these signals from Mars?
It will take approximately 10-ish minutes for the signals to travel from Mars back to Earth. So we'll not actually be seeing things live as they happen. You can't sit there with your joysticks controlling the rover as they come down. You're a few minutes delayed in knowing what's actually happening.
So everything is pre-programmed that's happening in this EDL phase.
Right.
Okay, cool. Well, that's really awesome. Thank you, Tony, for sharing your knowledge with us and explaining this in such a way that most of us can understand. It's really, really fun to learn about.
All right. Well, hope everyone is able to enjoy this lander and that it returns a lot of amazing science for us.
Yes, thank you all for joining us as well. Check out our social media for weekly resources and activities leading up to the landing, and tune in live on February 18th to check out this exciting event.